Hello and welcome to the next episode of the Klingberg Wing Mark II development. I'm Klingberg, your host. Today we're going to talk a little bit more about D-tubes. So let's get on with it. Hey, welcome back. We're going to talk about D-tubes today and some of the issues that I'm having with making them. And I hope you stick with till the end because I have some fabulous, wonderful offers to make for you. And you'll find some very good deals at the end of this video. So stick with me, or if you don't want to listen to me yammer through the whole thing, just fast forward and find out what those good deals are. In the meantime, I hope you enjoy this video and get some useful information out of it. We're out in the shop here today looking at the beginnings of the D-tube for the right wing. As I'm sure you know, the D-tubes are critical to the structure of this aircraft. They provide all of the torsional stiffness. They get bonded to the main spars that provide the bending stiffness and strength, and some of the bending stiffness and strength comes from the D-tube itself also. Really critical components. And it's turning out to the components that are hardest to make. It's been quite a challenge. If you've watched some of my other videos, and the links down below in the description to some of those videos, you can see the process that I've used to make D-tubes in the past. And I've made these D-tubes up to 7 feet long, and they come out quite nice. I've been very happy with that process, and took that process forward to make the D-tubes for the main wing panels. Now this D-tube, unfortunately I can't show you the whole thing, but it's 18.5 feet long. So it's considerably longer than the previous ones that I've made. And when I've given talks at various places, that's usually the first question that comes up. It says, hey, what's the longest one you've ever made? And I say 7 feet, and yes, I know it's going to be a significant challenge to make the really long D-tubes. So here I am looking at this 18.5 foot long D-tube, and you'll say, Raul, I watched the other video and I thought that you actually take the foam and lay it up flat on a board with the outer skin on it, and then when it's mostly cured, you wrap it on the form and cure it the rest of the way. And when that's done, you take it off, you put on the carbon fiber, that's the inner layer, and then you mold it all together. And I'd say, yes, that's how it was done in the other videos. But that did not work out for the really long ones. We ran into significant problems in making these. In fact, the one that you're looking at here is number 3. 2 of them have gone in the trash. And that's rather unfortunate because they're kind of expensive. But keep trying until we get it right. Anyway, so the basic problem was with the Mylar. As you probably know, I use this Mylar as a surfacing material. It goes around the outside and it provides a nice smooth surface finish on the outside. And usually in the past I've laid this up with the foam and the fiberglass that goes in here and shape it to the mold and then do the inside. That has not worked with this really long D-tube. And we've had problems with the Mylar buckling. I think I'll put a picture up. Actually, it'd be, where will it be? I'll put a picture up. Let's see. This is all reversed. Here, I'll put a picture up over here. There we go. I got it right. And you can see the wrinkles that are in the surface of that D-tube. That was number 2. And those wrinkles are actually the Mylar buckling, and because there's extra Mylar there. The fiberglass actually stayed attached to the Mylar instead of getting bonded to the foam. So it's completely loose in that section, flops around, and just generally a disaster. So buckling of the Mylar, vacuum bag was not enough to hold it down. And it's mostly because there's extra material. Now, why would there be extra material? Well, the Mylar will only curve itself to a planar surface, or it will only go on a simple curve. It will not go on compound curves. And the way that this mold is made, it was extremely difficult to build it by hand accurately enough so that it is a planar curve. So what ended up happening is I had to build a mold in 3 sections. There's a line right here that shows the first section, the second section, and out there's a third section. And that had to do with the length of styrofoam block that I could get to hot wire the sections of the mold. So we hot wired these, which by definition makes it a planar surface, a simple curve. And that's how the 7-foot long ones were done, and they molded up just fine. But you have to join the 3 sections together. And I was very, very careful in doing that, but despite years of building and great care, there was no way I could get this lined up accurately enough with 6 degrees of freedom to work with, because you have them lined up this way, this way, this way, twist, bending. You got all of the degrees of freedom there. You can screw up many different ways. And it's very difficult to get this absolutely straight. And what happened is generally speaking, the leading edge did not come out straight. Each one of these sections was shaped individually, and then I bonded them together. Now I used stiff straight edges to line them up, and line up this surface and the leading edge and all of that, and then did a little bit more sanding on them to straighten them out with a long bar, and still not straight enough. Plus we have the washout that's in here. There's 3.5 degrees, 4 degrees of washout in here from the root to the tip, and that can aggravate the situation. If you look at it from the leading edge back, there's an issue with the various sections being bent like this, and that can cause problems. And we went back and we measured, and it's really only out by 1/8 of an inch in a few spots. Like at the root end, the root end of this mold is actually dipped down about 1/8 of an inch. And you think you'd be able to work around that, but you can't, because it causes extra material to show up in the Mylar when it's bent down like this. That if you push the Mylar down there, it wants to buckle here, and there's no way that the vacuum bag can flatten that down. So we thought we'd go about it in a reverse process. We laid up the carbon fiber first on the mold, and of course there's release layer of plastic on there, and then there's a layer of peel ply, and then the carbon fiber, and we vacuum bagged the foam over that, because the foam will, if it's not dead straight, the foam will compress a little bit. And we did have some issues on the other side with buckling in the balsa trailing edge here, but we were able to just slit that and solve that buckling problem that way. I'll just sand it down when I put on the outer layer. But we were able to shape it to the mold, and we got a good part so far. We got a good inner layer and a good core here. I have to do some work on the seams, but this part actually worked. So far so good. So what I'm going to do that I hope works is, essentially by definition, each one of the 3 sections is straight. So I'm going to, as you can see, I got one section of Mylar laid on here already, and I'm going to tape this down so it's tight to the mold everywhere along its length. And this is about 6.5 feet long. And I'll be able to get that down tight. And then I'll come in with another sheet of Mylar here on the root portion, and I'll overlap this one slightly. I will cut all the way through the piece that's on the root, and then I will score this sheet and remove it from the core material here and finish that cut. So essentially I'm going to match cut each section of Mylar here, and I'm going to go with 3 sections of Mylar that are the 3 sections of the mold. And that way, if it's bent this way or some other way, it'll be okay, because each one is custom fit to its section, and the joints are butted together. Now this means that we're going to have to, we'll end up with a little bit of molding flash here where the 2 sheets are butted together, and I'll have to come back and sand that down and polish it out. Yeah, that'll be fine. The bigger issue was the fiberglass itself. We wanted to have one sheet of fiberglass all the way from the root to the tip for strength, but that's just not going to be possible. So what I'm going to do is I'm going to come in with a 4-inch wide strip of the same fiberglass, the same 3-ounce fiberglass, and I'll put that on the foam core first. And then I'm going to do this in sections. I'll lay up the root, the middle, and then the tip. And when I come in with the Mylar with the fiberglass on it, it will attach to this strip here. And if you have 2 inches of overlap, that is generally considered to be enough to that it's essentially a uniform piece of fiberglass then. And then the next section will go on. So there'll be a 4-inch wide strip of fiberglass underneath, joining the sections together. So the fiberglass will be budded on the outer layer, but it'll be attached to a strip underneath that's enough to transfer the loads across. And that should work out just fine. The carbon fiber that's on the inside is overlapped the same way as you're probably aware. We lay up the carbon fiber on the bias on the inside to take the torsional loads. And so there's multiple sections of it, and those sections are overlaid, 2-inch overlap, and it's a continuous piece of carbon fiber when you're done. And always works out well. So we'll just do the same on the outside. It'll just require a little bit of handwork to finish it off before we put the covering on it. So hopefully that's going to work. If that doesn't work, I have another backup plan. If we don't get all the buckles out of that, I got another way to go. I got a sheet here of sandwich panel material. This is the same foam, essentially. It's the lower density version, same thickness. And this has the same cloth on it, the 3-ounce fiberglass 120 style. And this has a peel-ply finish on it. This was a piece of sandwich panel that I'm using to make nose ribs. And I came back and I looked at coating this with glazing putty from the auto body industry. Let's see, do I have the tube around here somewhere? Who stole that tube? Here it is. It comes in tubes like this. I hear you can get it in gallon buckets. You squeegee it on, smooth it out, and let it dry, and then you sand it smooth. You can wet sand it. You can get as fine as you want with that. So essentially I'm smoothing out the surface, the peel-ply surface, with the glazing putty so that's smooth enough to not be an aerodynamic problem and to provide a smooth surface to attach the Oracal covering to. And in fact, after I did this, it dawned on me, hey, I could actually sand the peel-ply surface just ever so lightly first, take off the high points. That way I won't need as much glazing putty. Now, this will add weight to the aircraft, probably upwards of a pound, 3/4 of a pound. Which, you know, I'm kind of fanatical about weight, and we have very good reason for that. But at least I would have parts that way. So that way I'd do a wet layup on here, no Mylar, just put the fiberglass over the foam, wet lay it up like you normally would, and put peel ply on it. And after it's done, take the peel ply off, glazing putty, and then finish it with the Oracal. Now, by the time you do a wet layup on this, well, that gets considerably heavier. That's going to add another pound, pound and a half. So we're talking about adding 2.5 pounds to the weight of the aircraft per side. So 5 pounds total. 5 pounds out of 100, 5%. It's getting significant. So that would be a sacrifice in weight in order to actually complete the aircraft. Now, those are the basic problems. Those are the solutions I'm looking at. You stick with me and watch the other videos that are going to be coming in the future, and we'll find out if it works or not. So if you're curious about why I'm so adamant about weight, I got a video coming right after this one where I've done a little spreadsheet and discuss the various similar aircraft and what they weigh and why they weigh what they weigh. And please stay tuned to my channel and come and watch that one, and you'll see why weight is a very significant issue for this aircraft. Hey, I'm glad you stuck with till the end of the video. As I've been yammering on here, you're probably wondering, wow, where can I get a cool hat like that? I'm sure that's the only thing you were thinking about was that I got to have one of those hats, Raul. They're so cool. Well, I had these made up. They're finally embroidered in the lovely state of Wisconsin. And I think they look pretty nice. And if you'd like to have one of these hats, you go to the link that's down in the description, the PayPal link, and you shoot up 20 bucks to me, to my email address, which is also down in the description. It's rolkling@gmail.com. So you hit me up with 20 bucks on PayPal, and I will ding you right back with a return email that asks for your mailing address, and then out she goes. I get your mailing address, I pop one in a box, and off she goes to you. So 20 bucks for a hat. Every dollar from the hats goes right into building the glider. So not only do you have a cool hat to wear, but you're helping fund the construction of the glider, which is greatly appreciated. And in case you noticed, the banner on my homepage for my channel has a picture of the X-Plane simulator for my wing, which is way cool and tons of fun to fly. For those of you out there who like to fly X-plane or would even like to fly my wing before it's finished, the simulator is excellent. It flies a lot like the models, and you can get a taste of what it's like to fly this thing before it flies. I use it for practice. And I'll be glad to send you all the files that you need to plop into your copy of X-plane to fly my wing for a mere $15. And once again, you send that 15 bucks to PayPal, rolkling@gmail.com, and you'll get it by return email. You'll get a zip folder that has all the files in it, a few little instructions. Actually, go online. I'll link you to a video that has instructions on how you load it up. And we have lots of upgrades coming. You spend the 15 bucks for that baby, and that signs you up for life to all the upgrades that are coming. We got our fingers crossed here. The guy who built that simulator is working on a foot launch version. It's going to be so cool. You'll be able to go to any hang gliding site that you know of and set up there and actually foot launch off a hang gliding site. And currently you cannot do that in X-plane with anything. And I don't think there's a at-home simulator where you can actually foot launch hang gliders and ultralight aircraft. And we're actually working on building that in so you can go to any of those sites and literally stand up and run down the hill and launch your glider. And then when you retract the landing gear, when you hit G to retract the landing gear, the legs come up. It's pretty cool. So you'll get all those upgrades that come along, and for 15 bucks, you have a blast and have a chance to say, hey, I flew Rahl's wing before it was done. And what's cooler than that? So thanks for watching. I hope you enjoy all these videos. Come on back. Maybe in a few days here, I'll have that video on why I'm pushing so hard on weight on this thing. A very interesting spreadsheet that shows various aircraft like this, and the numbers are fascinating. So subscribe and click the notify button there, the little bell, so you get notification when that video comes out.